So the agenda for today is we're going to introduce our speakers that have agreed to present to us today. We'll be talking through virtual process planning technologies, including a few case studies. 3D scanning, we'll move to 3D scanning of large assemblies. And then there'll be a highlight on the Avro Arrow scanning project. When the presentation is done, we will open it up to Q&A. Like I said, if you can submit your questions on the Q&A feature of Zoom, and we will get to your questions. Our goal is to be finished at 3 o'clock sharp. So with that, I'm going to introduce our presenters. With us today, we have Roman Duplak. He's the National Strategic Business Manager for CAD Micro in Southern Ontario. Roman has over 20 years of experience in enterprise design and production engineering, 3D CAD, simulation software for electrical and mechanical and system methodologies optimization. He enjoys to leverage his past engineering, production, and business development expertise in aerospace, agricultural, and transportation industries. This expertise assists him to most effectively resolve various company technical issues and business challenges. This is combined with being a professional engineer, supported by his aerospace engineering degree and master's degree in engineering management with a certificate in systems engineering. Roman is joining us from Winnipeg today. Graham Wloch is the technical and sales manager for visual components. He's joining us from Detroit, Michigan today. Graham has an extensive experience in plant and equipment design, layout, and function. Using his technical background, he's able to understand production challenges and match them with simulation solutions. Graham, as I said, is joining us from Detroit, and we thank him for being a part of this. And lastly, today we have Rob Johnson from CAD Micro Solutions. He's the Director of 3D Scanning and Metrology. He's 25 years in the dimensional metrology business, working with products from handheld laser scanners to robot-based inspection cells, various roles in application engineering, customer training, business development, product management. He enjoys learning about different manufacturing and process operations and how metrology fits into these worlds. Rob is joining us from Southern Ontario. So with that, I will pass the baton to our presenters. Roman is going to take over, and we thank them for taking the time to present to our audience. Roman, over to you.
Thank you very much, Ron. Let me just share my screen first. So again, I want to extend a special thanks to the Manitoba Vehicle Technology Center, Ron, and everyone within the organization for providing us this great opportunity to share with you the various challenges that various customers have and solutions that may apply. And we hope that it will be a very educational webinar for everyone. And all of our respective contact information will be provided at the end. And again, a special thanks to the Vehicle Technology Center and everyone within CAD Micro and as well as Visual Components. So thank you very much. So I have a brief introduction of CAD Micro Solutions. So our slogan is we challenge the status quo, and we support our customers that are involved in various mechanical, electrical product producing OEMs and the respective tier suppliers. And so the solutions that we offer, they're specifically in optimizing engineering and manufacturing solutions, and we accomplish that further by involving our software equipment. And that's all in line with the Industry 4.0 transformation. So our offices are located, there's a few offices throughout Canada. We're a total of about 60 employees, privately owned and operated. The headquarters are in Toronto, but as you can see in the map, we have offices in Montreal that serves the Quebec and Eastern area of Canada. And then for the central western area of Canada, we have also an office in Cambridge, Ontario, next to Waterloo and Kitchener. And then also offices in Calgary and Westminster, BC, near Vancouver. And so at the moment, we have 3,000 plus customers that support the company. And we've been in existence since 1983. Some of the solutions that we offer, I'll just quickly do a quick summary of that. So one area is we provide product engineering software solutions, 3D CAD for mechanical application, Also 3D CAD that's applied for electrical and PC board design. We also provide different types of simulations tools as well. So plastic injection molding analysis to optimize your plastic injection. We also provide electromagnetic simulation tools as well. Forgive me, but I skipped somehow the previous slide, so I'll just go back to it briefly. We also provide product data management and lifecycle management solutions through our SolidWorks platform and the Dassault systems. And then the area that we're particularly focusing on in this webinar that we also provide solutions on is 3D scanning metrology, specifically equipment involving Gom and Zeist for quality part assembly control, as well for reverse engineering. Furthermore, we provide solutions in production optimization and CNC machine dyeing. So a particular area that we're also focusing in this webinar is visual components, which is one of our strategic partners, as well as other solutions regarding CamWorks and CAM. And then also we provide other software solution in immersive reality, augmented reality. So augmented reality, virtual reality for the manufacturing applications and various training applications within the manufacturing industry. And the final area of expertise we offer solutions is the advanced manufacturing solutions, 3D printing. So per se, 3D printing machines that provide higher speed printing, also 3D printing using materials of plastic-based and composite. Composite meaning it's a mixture of plastic and fiber-based, as well as we provide metal 3D printing, and particularly when it comes to very large components that need to be 3D printed, we can go up to a meter of a cubic meter size printing, as well as 3D printing circuit boards. So without further ado, that's the summary for CAD Micro Solutions and visual components. And now our esteemed expert of visual components, 3D manufacturing simulation, Graham Wloch, will take over. Graham?
Hi guys, everybody hear me, see the screen? We look good? All right. Well, my name's Graham. I'm from Visual Components, and I'm going to take a couple minutes here to go over what simulation is and how it can be applied and what it can actually solve for you. Okay. I'll introduce myself again, and I'll be provided with a copy of this deck for later. Real brief, who we are, why make the investment, again, what we solve. We'll talk about 2 case studies where customers have used the same platform and used simulations in different parts of their business. And we'll just kind of wrap it up at the very end and kind of recover everything that we've talked about. A little bit about us. Visual Components was founded back in '99 by the individuals on the left-hand side of your screen. These are the same guys that back in the mid-'80s founded a company called Deneb Robotics. And then Deneb was eventually bought up by Dassault and turned into present-day Delmia. So our simulation solutions go back a long ways. And we've got quite a bit of experience in what and more importantly, what not to do with simulation. You can kind of see our progression where we continue to release. Our modern history is probably 2016 and beyond, where we made our switch to our 4.0 platform. You can see around the world, lots of licenses, lots of consistent sustained growth. We have about 70 people in 3 offices, Helsinki, which is the home office. We've also got an office here in Detroit and another office in Munich. Myself, again, I come from a mechanical design background, doing end-of-arm tooling for ergonomic lift assist, overhead rail systems and things like that. So from very early on, it was very important to understand how things went in order and what the process was like. So it made the transition to simulation pretty simple. When we talk to customers and when we find them being interested in simulation, we always ask the question, what is it you're trying to solve? What doesn't go right in your world? What do you think simulation can help you with? We update these quarterly. But as you can see, you know, there's all over the board. People are looking to simulation for answers. And I think it's important to understand that, you know, all of these, some of these, nobody's alone. These are common issues that plague manufacturing. Most of them coming in this being slow and not agile, unable to validate continuous improvement, and just things take too long. And we find that to be a very common issue. Most of the customers that we engage with for the purpose of simulation want to use it for internal things. You know, they're sick and tired of consultants that don't know their world like they do, and they want to own their own process. They want to become masters of their own destiny, as it were. When you look at simulation and should I simulate, it really comes down to, you know, can you identify a pain, and can you justify the investment into simulation with an ROI? The goals of simulation when you engage in that pursuit should be an ROI of 12 months or less. You should have identified pains that we can eliminate, growing sales either by, you know, again, sales or just production, and then to make sure that not only new but existing systems are optimized. Some of the supporting data on the right-hand side of the screen speaks to some of what we've seen customers experience. While some might be a little extreme, you can imagine that, you know, if you've taken part of sales or project reviews or process reviews, and there have been meeting after meeting after meeting, because it's all 2D and it's all PowerPoints. If you were able to visualize that actual process, think of what you could save just in time and effort and labor by eliminating the need for as many meetings. When we talk about simulation, it's also not a Band-Aid. It's also not something that applies to one thing only. Okay. In this world, you've got animation on one side, which is just pretty pictures. On the other side, you've got emulation, which is very, very detailed, like controls analysis and validation. Then you got kind of simulation that sits in the middle. Simulation can do both. It's absolutely the pretty picture, and then with the right platform, it can be used on the other end to do the controls details. But more importantly, it gives you an understanding of exactly what's going on in your world, from capturing concepts and ideas very early on, hand off to process optimization with the engineering team, and doing resource allocation planning. And then for that implementation of the offline program and controls validation, simulation can be used at every single step along the way. You're not limited, and you're not left relying on what that next step is going to be, because with simulation, you can take it all the way through that process. A couple of customers that have actually taken simulation and applied it to what they do, we'll talk about them for a couple minutes. NIMAK is a company that used visual components on the front end. Okay, I'm not going to read the whole slide. You can do that. It'll be provided for you later. But NIMAK was a company. They do welding equipment, robotic welding tools, welding tables, things like that. And they were always left with the problem of, because they make custom solutions, really being unable to show a customer what that custom solution will look like inside of that customer's environment. They could tell them, they could show a video, but if it wasn't what that customer does, there's always something lost in that translation by somebody being not able to look at a process and being like, oh, I get it. That's my world. You're right. That'll make my life a lot easier. So what NIMAK did was they brought on simulation for that sales process. What they did is they actually took a lot of their custom equipment, things that they've made, things that they've done, and they imported it into the simulation environment and brought it to life. They added functions and features and motions and movements and properties. And now what they're able to do is take their very custom equipment, create an environment that resonates with that customer, and then actually show the customer their equipment that way. Okay. The next slide here, this is actually a video, a promotional video that they actually were able to create in the simulation environment and export. Again, this is custom CAD files they already had. They added motion, they added movement, they added orders of operation. And now, instead of just talking about it, they can actually show this inside of that customer's environment so that customer has a better understanding of what they have to offer. This is something that's directly exportable from the simulation platform and has gone quite a ways in their ability to really highlight, show, and expose potential customers to what they're capable of. They've also taken this and they've taken that next step, like Roman had mentioned, and put this in a virtual reality environment. So not only can the customer see exactly what's going on here in the simulation environment, but they can also actually experience it in a virtual environment to scale. And again, this is just something that NIMAK has created through simulation and something that's helped them with their process. Let's go to the next one here. And these are just a little quote, and it talks about visual components in simulation being scalable, right? Remember I said it can be used early on in capture concepts and ideas, and then by engineering, and then by controls guys, all increasing communication internally. So it almost becomes an enterprise type solution for a product cradle to grave. And that's the great thing, is that it can actually grow with you as your needs grow and as things change. The next company that we want to talk about a little bit, AGCO, used it in a little bit of a different way, okay? So where NIMAK used it very early on in their process, and they were mostly concerned with capturing concepts, ideas, using it as promotional, which is great. AGCO had an interest to use it more for process validation. So this would be that next step in the process where they said, how exactly are things going to fit together? So this is also important because simulation isn't just for new manufacturing or new processes. This simulation in this case was for existing processes. So what happens is, when you've got multiple lines and you've got tons of interoperability and you've got something, on one side of the plant that can affect something on the other side of the plant, you really need a way to understand that as it happens, what it looks like, and what all of the negative unintended consequences are of anything that you do. And that is where people have the issues with continuous improvement and optimization, not hitting OEE and things like that. So what AGCO did is they actually took and they started virtually making changes to those lines. If you've ever been a part of cardboard city events where cardboard cutouts are put on the floor and people walk around and they pretend to do a process, done right, it can be pretty effective. I'm not going to lie, it's been done forever. But what AGCO did is they took that next step and they put that in a virtual environment. Now what they were able to do is, rather than just have people walk around for a couple minutes and try and extrapolate, they were able to see what actually happens over an 8-hour shift, over a week of production, and over a month. And they're able to do that all within a couple minutes and then extract that data and validate exactly what those changes were going, what impact those changes were going to have on their processes. Now, this is a whole lot more convenient because you can run a scenario where you say, what if A? And then directly compare that to what if B, understanding all of the things that go into that process. Improving Op 120 to produce something, at 15% greater rate does no good if Op 130 can't handle it. So this is a really good way to not only go from cell level to line level to plant level and really have a great understanding of what those processes look like. Now, what they did is they took it inside of that engineering and they said, well, if we're going to do all of our process times, well, let's take a look at our offline program. let's take a look at all our cycle times. And then what they did is they actually took these simulations to their suppliers and said, look, this is what we want. All of a sudden, AGCO and their suppliers were on the same page. And all of a sudden, they found that lead times, they found that installation, they found that all of the things that used to plague them with changeovers and improvement and updates and upgrades and model changes, those all went away because everybody was on the same page thanks to the simulation. Now, what they were also able to do is they were also able to take this and they were able to export it into a virtual reality environment. So now what happens is when they have Kaizens, instead of that cardboard, what they do is they put the headset on people and say, here's your workstation. Here's that virtual environment. You're on the manufacturing floor. And what that does is that provides the people that do the process a way to directly understand what that process is going to be like. Because let's be honest, rarely do the people that do the process design the process. And what they're able to do is they're able to offer suggestions, input, validate ideas, make those changes. And then what happens is it absolutely 100% reduces the need for additional troubleshooting once things go live on the floor. We've all been a part of that put out the fire because things pop up and it seems like you have one out only for the next one to spring up and for there to be an issue. In a simulation environment like this, given the right tool, you're able to do potentially product arriving. You're able to do things like kitting areas. You're able to do dunnage deliveries. You're able to schedule all kinds of things like that, because not only can you do robots, you can do forklifts and AGVs and all kinds of different resources within that environment and really actually understand how they operate together. This is one of their lines. This is walls, overhead, floors, everything, so that they were able to take and understand what that process would look like. And they took it from one line, and once they were done with it, they were like, okay, well, let's do the other 5 real quick and see what all of them look like together. AGCO actually now has an entire room in their headquarters dedicated to VR. And the reason for this is they saw the value, and now when they have ideas to sell up the chain of command, they're able to, again, just do it in a virtual reality environment, show exactly what they're talking about, and get that buy-in, saving time and effort and explanation, and make the process much smoother and more efficient. Couple quotes again, to really not only use it as a pretty picture, but to validate times, to validate processes, to validate changes, to share internally and engage their employees, and even as that extended to their suppliers, they saw a huge value, and their use is just continuing to grow as simulation dominoes into every single part of their process. This layout is actually one of their other layouts. And you can kind of see in this case where you can take existing layouts, you can take existing floor plans, and you can build right on top of them. So it then becomes more of a, instead of color by numbers, it's almost a factory by numbers. It's important for all of you to understand that while we may make a solution tool, we don't know your world like you do. You're the experts. You really can be the ones that take control of exactly what happens and understand and own exactly what it is you do. And when we talk about scalable, again, it's that cradle to grave. You've seen how it can go from capture concepts and ideas, detailed cell level analysis in that last slide where the robots had been taught their sequences, line balancing and optimization in the last video. How many people do we need? What can they be responsible for? How utilized are those humans? If you can do the job, but your human resources are at 95% utilization, it's probably going to cause more problems than it is solving. And in the case of AGCO, doing multiple lines to get that plant-wide understanding. And then again, even beyond the four walls to get a better understanding of your supply chain. So, I mean, to recap and kind of sum up, again, those goals need to be, can I justify this in under 12 months? Does it eliminate absolute identified pain? Can I grow and am I optimized? And one of the other things, you know, that we like to talk about is, you know, when that investment is made, right? We had a customer that did a launch and it was an absolute unmitigated disaster. Well, they weren't a customer at the time. It was $30 million loss. They actually had to outsource to their main competitor in order to meet their promised delivery. They couldn't figure it out. It was too big of a problem. By bringing consultants and saying, well, let's go back to the very beginning, they realized it wasn't going to fix their problem. So instead, they chose to simulate it. They did so after the fact, and through simulation, they were able to validate the what ifs very quickly, fix their mistake, and eliminate additional losses. We've seen footprint being reduced. We see CapEx averted by customer understanding that they could actually, through a different configuration, achieve the same throughput with less equipment. They invested early and all of a sudden we don't need that on the floor, and they saved the space. We had a customer that had a crossing conveyor system, and they took time A, time B, and time C, added them together and said, here's my throughput. But what they didn't understand was, you know, the blockages and how that system really operates when you put things together. They simulated, they said, wow, that's something we never even thought of. And they avoided a penalty because they were able to fix it before implementation and before they said, I don't know what happened. What do we do now? Right? The idea is to invest early. The idea is to make it part of who you are and what you do, to really embrace the technology and the tools that are available to you. One of my favorite things that I ever heard, it was from a customer about a year ago now, where he said, it's not the big that eat the small anymore. And that's how it was for years. Big company, small company, they didn't stand a chance. Now it's the fast that eat the slow. And, you know, Blockbuster, Borders, we see all these huge companies that don't take advantage of the technology and tools in front of them. They say, we'll do it this way because we've always done it this way. Meanwhile, other people are making those changes. Meanwhile, other people are embracing advances in technology and offering things that either you don't or you can't. And when, you know, you go and two people have a pitch and two people have a quotes, and one person says, look at my PowerPoint, understand, don't you get it? And the other person says, here, put on a headset, I'll walk you through it and you can actually see what we're going to do. And that's the kind of thing that simulation can bring to the table. And that's what simulation can do for you. No matter who it is, it needs to be a tool that you are working with to make your processes as good as it can and make your company as successful as possible. That's all I got. That was simulation at a 10,000 foot view. I think Rob is going to be up next. And if you guys have questions at the end, you know, feel free and we'll answer them any way we can. Thank you.
Okay, can you see my screen? We're good? Thank you. Thank you, Graham. Great presentation, and I took a lot away from that myself. I love the fast eat the slow mentality because it's so true, and that's going to come across a little bit in my presentation as well. Another great quote you had was varying worlds of details, and that is really metrology in a nutshell, because the way one manufacturer makes his parts, the way another one does his, big, small, tight tolerance, loose tolerance, whatever, it's varying worlds of details, and that will come through as well. And one of the things I've tried to do in this presentation is try and touch on a few points in a couple of different industries, not just large scale parts that really apply to this varying worlds of details. And another thing that Ron mentioned right at the very beginning was just about technical sharing. It's another aspect in the Canadian and a little bit in the US manufacturing landscape where we don't technically share between our supply base and our OEM or even plant to plant unless we're forced to. And there's so many initiatives within Industry 4.0 in the metrology world that I'll touch on that really could benefit from us leveraging technology even in our space on the technical sharing side. So again, thank you everyone. Great presentation, and I'll just go through mine now. Again, I'm Rob Johnston. I'm the director of our Metrology Systems at CAD Micro. I've been in the industry for about 25 years, which means 25 years of trying to find people that make a bad part, because nobody ever admits they make bad parts. It's just finding people that are looking to improve their processes. So the title of our presentation is 3D Digital Manufacturing Inspection of Large and Complex Assemblies. So obviously large and complex is always relative. I'm going to be focusing on vehicles and subcomponents today. Companies that are trying to move away from manual inspection and inspectors, and then some complex GD&T assembly or process analysis. So some very high-end type applications and people pivoting away from manual inspectors, people with calipers, tape measures, grinding stones in their hands to again, take some of those 4.0 initiatives into the real world. So at CAD Micro Solutions, as Roman mentioned, we're a partner for several companies in Canada. One of them is 3D Systems. Roman mentioned about the use of 3D scanning data in a reverse engineering application. Today's webinar isn't about that, but we're a certified 3D Systems partner. And another one is called Origin. Origin is a process analysis software. You'll see a little bit of that today. And we have two main hardware manufacturers that we're partners with in Canada, Gom for 3D scanning and Gom for 3D scanning and inline or at line, near line process analysis and data collection. So where are the big three metrology areas of interest? They all fall into kind of three categories. One is dimensional metrology, such as profile of a surface, true position. Another one's flush and gap, such as the edges around a bus or where a window meets a frame or the way your door closes. A lot of those measurements are called flush and gap. In the automotive space, they're heavily used for wind noise and the cosmetic appearance. In large scale manufacturers, it's more about door fit and safety as well. And then something that's really evolved in the last few years is what we called cosmetic defect detection, which has historically been humans. We've had inspectors at the end of lines looking at parts under a magnifying glass, looking at with just their eyes and looking for surface defects, and is the product good enough to ship to a customer? So a lot of that, again, with 4.0 initiatives is being taken out of the hands, and the subjectivity of training, the subjectivity of humans, and moving that into the online, not cloud-based, but inline metrology systems to go and evaluate when is a surface defect an actual defect, not just a dimensional metrology component. And all of these are wrapped into what we call process control, or what do I need to measure about myself? What do I need to measure about my parts? Or what do I need to measure from my supplier or my customer across the street or my customer next, whatever it is, to understand my process control. And that is the root of all of the Industry 4.0 initiatives is what data can you gather, whether it be through systems integration, through big data or whatever, what data can you gather on a regular cadence in order to get better process control? Some of the problems that are hitting the world, not just North America and Canada, are some of the outside influences of process control and some of the variables associated with that. Starting at the top, skilled labor and trained technicians. We're just not training people in the metrology measurement space anymore, and we're relying on software tools to do a lot of those jobs for us. So one of the initiatives is to create systems that make it easier for operators, do more with less people, kind of a thing. quality and warranty costs are huge for companies. The more they can get their processes under control, and it doesn't mean making a car every 2 minutes. It could be making a large vehicle once every 3 days. The last thing anybody wants is that vehicle coming back in any volume capacity for warranty reasons. Another big process control challenge is integrating Industry 4.0 big data. You know, a lot of people used to have CMMs in the past, and they would measure their parts, or have inspectors where they would have specific controls of things. Now you're getting into a world where you say, well, I'm going to measure everything. So you get out your laser scanner and you scan the part, and you create 10 million points, and you know 10 million more ways that your part's good or bad than you did before. And how do you manage that and drill down into that? A whole other challenge people are facing. Variable manufacturing, you know, contracts aren't 7 years anymore. They might be 7 months. So being able to change on the fly, and what does that mean for your metrology system? And then obviously people are always searching for consistency and traceability, documenting their controls, documenting their measurement plans, and metrology is a big component of that. Okay, so I'm going to go through 3 pillars, what we call them. Here's a picture of one of our robot cells that we have. I'll just be describing that in more detail. But I'm going to be going through 3 main pillars. One's called Simplify Your Metrology Network. Some of the core competencies that a lot of industry initiatives, a lot of companies are taking on to simplify their life. Automated dimensional measurement equipment, what I call nearline. So it may not be right in line like we think of automotive manufacturing or high volume manufacturing, but being able to take large pieces of equipment, setting them into a work cell, and literally inspecting 100% of the part as part of the IO 4.0 initiatives, or just knowing more in a very quick amount of time. You're talking about 20 to 25 minutes of 2 robots being able to do a full frame of a tractor, a large SUV, a cargo van, things like that. That we just haven't had before. Laser scanning has been around for a long time, but now the systems are scaling, the data is scaling, the accuracy is scaling, and we'll go through a couple of small examples of that. And lastly, we'll talk about inline or nearline, what I call dimensional and surface defect detection. So in the sheet metal space, in the body in white, in the press shop, in welding, in anything in terms of metal fabrication, again, a lot of the surface defects have been done by humans, and now there are systems in place on the ends of robots to do that for you with AI, virtual reality, AI built into the systems as a learning algorithm to tell you if your parts are good or bad. So let's get started in terms of some of the top 3 or 4 things that we see as a metrology trend related to Industry 4.0 and simplifying your metrology network. If you look at a vehicle, and yes, there's one train thing on here, but as you fabricate parts and go through an assembly process all the way through final assembly, there's lots of little variables along the way. And the 3 that we're going to talk about today is Industry 4.0 system interoperability, or sharing things, as Ron put it at the very beginning of his presentation. Process monitoring, meaning tell me not just that my part's good, but my process is good, and I need to do it fast. And then, of course, some of the higher end things, which are CAD. CAD has changed significantly, whether we believe it or not. CAD's been around for 40 years. How much could it have changed? One of the big areas is with MBD and PMI. Some manufacturers like SolidWorks, CATIA, Creo, and all these high-end systems allow you to embed MBD and PMI. And what does that mean? And I'll go through a slide on that. So let's start with process PPK monitoring. And a lot of times statistical process control has been often thinking of, well, I got to have 10,000 parts to justify that, or I got to be, got to be in high volume production. And that's not the case. Low volume production is where you need, and especially during prototyping and rapid prototyping, is where you need to understand if your process is capable and what your process tolerances are. And what's come a long way, this is a medium-sized sheet metal part off of a tractor, where we can now scan this part in probably 2 or 3 minutes. And in the past, it used to be write a program on a CMM, That would take 2 or 3 hours. Run the program on a CMM, that might take 10 minutes. So you can see that in a third of the time, I'm getting almost 10,000 times more of the data. And we're getting all of these wonderful plots. And where things have evolved to is now I can actually put 5 parts virtually on top of each other and walk through them and actually show me a color map of my range of parts, meaning you can see the red is on the high end, the blue is on the low end. What is that? What does my process tolerance really look like? Where that is now evolving to is being able to do this in seconds, not in minutes. So if you've got a supplier or you've got a press shop within your facility and you're banging off, I don't care if it's 5 parts or 50 parts, you can scan them really quick and really get an idea of your process tolerance now. And of course, where that blends into is looking at your PP or your process your process actual performance part to part. You can see there's some high red areas up in the top part. Is I know across these 5 parts that from my process point of view, there's where my problems are. But when I look at where the parts are relative to the nominals, meaning where relative to the center of the zone, you can see that this is not a capable process right now. So this is plus or minus roughly 1.5 millimeters all around. But you can see the difference between looking at PP and PPK. And we used to have these people in the related to the engineering department that would crunch all this data, and we'd find out, usually an hour or days later that, oh, the parts we shipped aren't actually capable, and or they'd be sitting in our warehouse till we knew that. You're literally getting these data now in minutes of telling you whether not just it's good part, bad part, but now good process, bad process, and being able to loop that data back into engineers' hands. And it doesn't matter the size of the part. This part could be the size of a nickel. It could be the sidewall of a bus. Yes, your data acquisition time is going to change and your tolerances may change, but it's being able to drill down into the data, what you need to get what you need out of it. So that's a very high level of where industries are going with this information. Is I don't want just good part, bad part anymore. I can get that fast. Now I need to know the 10 panels that I've manufactured, even though my supplier said they're all good, how do I know where they're going to fit relative to a process tolerance? Another thing that I mentioned was about how CAD MBD has changed, or CAD systems have changed. And one of the biggest changes over the last kind of 3 years is the ability to embed MBD or model-based definitions on your model. This is such a valuable thing beyond the advantages of the CAD department, the PDM department, the product lifecycle management, all things like that, is that Metrology Systems downstream can take advantage of all that. They don't have to rewrite their programs. They don't have to go and figure out what needs to be evaluated and apply all of those rules in a software. All of that intelligence is now built into the model. So when you get downstream, you can take advantage of that right away. And after you've scanned the part, have it instantly analyzed. That's a standard feature in most softwares now, that if you've got the intelligent CAD model, you scan it, you load it in, it's automatically analyzed. So where I said before, CMM programs, I don't care if they're taking 10 minutes or 2 hours or whatever it takes based on the level of detail, it's no longer required. You can literally load the model, analyze the scan data, and you're done. A big change that a lot of people haven't taken advantage of yet because they're not having that technical sharing conversation between the OEM, the supplier, or the internal customer level. The other thing that's changing that a lot of people have gotten frustrated with, and this goes back to the varying worlds of details and technical sharing, is the ability to share actual programs between devices. And I call this a single platform for metrology inspection. There are a couple of different vendors that do this. I'm going to just highlight the way that Gom does this, that if you go all the way up from a handheld scanner, something that you may use on the front of a bus, the front of a tractor or front end loader, something that's small, portable, gives you lots of data, all the way up through larger optically based trackers, higher accuracy kind of plant level systems, robot systems at the component level, robot systems at final assembly. the very unique thing that the market is going to is a unified platform across all products. So if you know how to use one, you automatically know how to use them all. The only difference as you go from left to right is there's one extra layer of, oh, I got to teach the robot what to do. And I'll show you a little bit more about that in a second. The other thing that's really neat that GOM provides is a free software. Everyone likes that word free. Is that if my supplier has if I know my supplier, whether it be internal or external, has a scanner, he scanned the part, I can actually get the scan data from him and do the analysis on my own in free software. I'm no longer dependent on my quality department. I'm not dependent on engineering going and buying expensive software. I can take the CAD, take the STL and overlay it and get those plots that I had on the previous screen all in the free level of software. It's fantastic that way. So single platform software solutions are becoming more and more prevalent. So you can address that skilled issue, train people at the beginning that I mentioned, and train them on one metrology platform that allows them to use multiple different devices. Gom Inspect is a very unique software in the market in that you can actually use it to do three things that are shown on this chart. One is all of your traditional inspection, surface profile, true position, distance between things, all of that. It doesn't matter the size of the part. That's that kind of inspection point panel in the middle. The other thing you can do, which I'll highlight in a few minutes, is about surface detection, is that it's the same software that will allow you to detect, do you have a scratch? Do you have a bump? Do you have a nick? Treat that as this, treat that, add your own intelligence to it. The software does that now too. And lastly, what's very popular that I already mentioned about is the whole flushing gap, which is the gaps between two seams and how to analyze them, how to report them. And as manufacturing is changing, going to electric vehicles as well, is using the same profile platform for large parts. So when you've got, this is all green, so it's saying it's all good, but using the same thing for GD&T, for surface deviations, for all of that, again, getting this data very, very quickly and not compromising the accuracy. And it all starts with metrology grade data. You've got to have a scanner, a scanning system that produces high quality points that allow you to do this once. You don't want to keep measuring and measuring or trying to figure out where your measurement uncertainty is. So I'll just give you a quick video. This is a very relatively new product where in the hand scanning market, one of the things that you'll notice about this part is that there's no stickers on it. There's no markers. There's nothing like that. That the guy has a scanner device in his hand. He's capturing hundreds of thousands of points a second in this case on a very large part. This is for obviously a tool. And as long as the part in his hand can see the optical tracker, he can create high quality, lots of data very, very quickly. And this is again just a portable metrology tool that you might see out there in the market. Okay, so that was my quick little thing on simplifying your metrology set, which is better sharing of CAD data and looking into MBD and looking at process deviations. The second part of this is regarding automated dimensional measurement. And automation is kind of a hard thing because they think, I don't make a car every 60 seconds. I don't do this. I don't do that. Tell me, how could it benefit me? And if we go through this, you're going to notice I have two systems that I'm going to talk about, and I'll quickly go through each one. One is what I call a size constrained system, meaning you can't just keep making it bigger and bigger and bigger. But that's all about laser inspection. I'll talk about that. And the second one is what I call scalable, which is from the component level to large parts. And large parts could be a bus, it could be a tractor. There's no set scaled volume that you have to abide by. There's some things that come with that, let's be honest, but you're no longer having to just have a scaled constraint that way. So the first one is what we call a Gom Scan Box. This is what we call a Scan Box 8 series. Two robots allow you to scan the whole part in about 35 minutes, start to finish, and you get a color map like this. And again, great for early phase development, great for understanding once you've bolted things together, where your deviations lie, what you need to fix and what wasn't assembled properly. Absolutely fantastic tools. This one here on the left doubles as a component system as well, that allows you to put the part on a fixture, and while you're not measuring the body, you can be measuring components. So it can be interchanged a variety of different ways. And again, just another close-up of a large component, being able to check for surface profile and all the mounting locations. And again, as I mentioned before, all of your robot paths are now programmed from within the metrology software. This is really important because in the past, I mean, sensors on the end of robots have been around for 20 years, but you've had to require a robot technician. You've needed multiple people monitoring the system at all times. Now the guy who decides how he's going to measure the part or what he needs measured on the part is also going to control how he's measuring the part. So very simple motion control now built into all of these softwares as well. And again, I'm just going to play a video for 1 minute to show what these systems look like in real time. So there you can see that's a fairly medium-sized SUV frame, two systems working in conjunction with each other. It's a blue light fringe projection system that allows them to position, reposition, and capture the data on a wide area very, very quickly. So this is an example of obviously an automated solution. There are also solutions where these can be just mounted on a cart. So you could put this on a wheeled cart, you can have it move around your equipment. And that's a great phase one approach of just being able to learn how to use the system, gather the data that you need to understand your parts. And as your volume increases, as your demand on the system increases, you literally just put a room around it and you're done. So I'll just keep moving on. The second product is in these large scale manufacturing is called an AI cell trace. And this is very different because you're no longer dependent on a room. You're no longer, so even though we're showing it as an assembly line here, this could just be literally a structure out on your floor, but there is vibration compensation. It's calibrated within a 30-degree temperature range, and you're not worried about robot drift or robot correction, in that the camera system, which is all scalable to the size of parts that you need, whether it be a single component or a large vehicle, is tracking this as a tool. So there's really no relationship between the measurement system and the robot anymore. This is just a positioning device, and all of the metrology, the high accuracy, is between the relationship between the cameras and the end of tool. And that's what's calibrated. That's your traceable component. This system is very different, that it's not just looking for surface profile like the scan box was. This is actually looking for mounting features. So this is where we want critical diameters, critical true positions, critical mounting faces of how the parts bolt together. Because if something is out of tolerance, then it's not going to assemble correctly. And where that comes into play is being able to do this at high speed, where your data acquisition time is actually less than a millisecond. So I'll just kind of, again, mounting features for flush and gap, scalable with active tracking. And just a couple of the real important pieces that we're installing out there. Motion sensors, so that if there are vibrations coming through the floor, that can be compensated for. The cameras that I spoke about on a scalable network, and then a carbon fiber tool that we're tracking through strobed LEDs. So this actually is flashing lights at a very high rate that the cameras are picking up. And this actually becomes a calibrated CMM volume. So roughly to about 100, 150 microns, depending on the size. So just show you how quickly this is in motion and how it's being used. This is an example of this and the size of the rigid body. These are just strobing LEDs. And when you've got things, it's literally just going over to the part, flashing a light, getting the true position, and or getting the location of features and carrying on. So that's a very modern tool that way. The last section that I'll talk about is something that's I'm really excited about. It's something that we've got installed in multiple locations in Canada, and that is surface defect detection, which is taking the subjectivity of when is a scratch, when is a weld flash need to be removed, when is something whatever, taking that subjectivity out and putting it in the hands. Again, all scalable in terms of small parts all the way up to very large vehicles. So when we think about surface defects in the, let's call it the sheet metal, the frame, the outside surface market, we've often had inspectors have gloves on their hand, running their hands over the part, looking for burrs, dents, basically before we ever paint it. And then they're going and marking it up, or they're taking their stone, they're rubbing over the part, and before it goes to painting. And this is a very labor-inducive process. And what they're looking for are things like bumps, dents, sink marks, waviness, draw lines, all these traditional things that happen in sheet metal forming operations. And trains people, it takes a long time to train people how to look for these things. And when you're looking for, again, that really nice cosmetic finish, which is your end product that's going to your customer, how are you doing that? So this is an example of now what we call an ABIS system. And this is showing it on a sheet metal part. And this part was actually done by AGCO. And this is the part here. You can see it on the large part of the tractor up front here. And the size of just how big that part really is shown here. And there's your ABIS system here. So this is a system that, a large scale manufacturer has invested in, just to say we gotta, if that's what the customer is looking for before we manufacture that, we want these to be burr free, paint free. We don't want to be correcting things at the end of the line, and we're going to put these things in place so it's coming out of the press, it's being scanned like this, all optically non-contact, very high rate of speed, and I'll show you that on the next slide. But essentially, these tools can be used for within your press shop, with at the component level, or right in line. So in line would just depend on your volume. But essentially, now instead of manually inspecting for things, this is another installation at BMW, where in a camera view, how quickly you're able to walk over a part and look for all those things, and for all about quality control. So thank you. That was just kind of a real big summary of some of the latest things that are going on out there in the metrology market, from looking at your process tolerance, your process time, through automated inspection, inline or nearline, and then obviously transitioning into surface defect detection. So thanks a lot, and I'm going to hand it over to Roman.
Thank you very much, Rob. That was a wonderful presentation. Very informative, I found, for myself as well. And also, Graham, thank you much for your presentation as well. That was also very informative. So as promised, I'll now start with the portion of talking about the project that we work on, the Avro Arrow replica, the 3D scanning it, which was done just this past December. So in the town of Stayner, Ontario, which is located approximately an hour and a half north of Toronto, roughly half hour west of Barrie, Ontario, there is an airport type of a small airport and museum called the Edenvale Aerodrome Airport Museum. And in that museum is the replica of the Avro Arrow. And for some of you that know the history of the Avro Arrow, you probably know it was originally designed and a few prototypes were built in the early to mid 50s. And it was canceled by the Prime Minister at the time, government of the Diefenbaker. And this is a replica that was made specifically for the purposes of the movie that was created in the early to mid 1990. I think it was made in 1992, 1993. And the replica was made specifically for that movie, where one of the star actors of that movie was Dan Aykroyd. So the replica is inside the one of the hangars there at the airport museum. And for your information, everyone, there's Rob on the far left corner picture there, standing and looking at us here. But it gives you good context of how large this aircraft is. This aircraft is roughly the size of a whole tennis court. It's quite big. And so the project here was basically to do a point cloud 3D scan of the whole aircraft for a non-disclosed client in order for the purposes of creating a model that would go into a virtual reality environment. And so we provided basically the service of providing a full 3D model that was fully rendered and ready to be put into that virtual reality environment. So what we did is we provided the equipment and the service to do the actual 3D scan, and it's on a mechanical tripod. As you can see here in the red dashed circle, it's a little triangular portion there. You can see it in the background behind the aircraft. And at various different strategic locations, 360 degrees around the aircraft and at various different elevations, we scanned the whole aircraft replica. And the point clouds, the spacing of each point of data that was collected off the aircraft was literally a 1 millimeter distance. And the accuracy from tip to wing, from wing tip to wing tail, the accuracy was 3 millimeters. So it gives you quite an amazing understanding of what kind of accuracy is achieved for large 3D scans. When we talk about 3D scans for metrology application purposes that Rob was mentioning, there's other equipment that is used for very much smaller parts for quality part control. Obviously, the accuracy is much bigger, much greater, to the level that aerospace requirements require or automotive production requirements require, just for context comparison. So I just want to also touch base upon the steps that we're taking and the labor time that's required to collect the 3D point cloud and then come up with a final 3D CAD model that was created finally in SolidWorks, and then that was used for being brought into a virtual reality environment. So the actual scanning time to attain the 3D point cloud was roughly 3 hours. So, which is very little, obviously, for the whole aircraft. So that's the time that we actually spent within the hangar scanning the whole aircraft replica. What takes a lot more laborious hours is processing that data, because each point is strictly a point in space. Each point is not connected to one another. And so those connections those relationships between those points need to be made. And that's where it took in this specific project about 40 labor hours of a person sitting at a computer together with the assistance of a special type of software in connecting those points relative to another in order to create a 3D CAD model. And then once that 3D CAD model is created, so that 3D model you see is actually in the picture on the bottom left. It looks kind of like a black and white picture, so to speak. Then the actual rendered Avro Arrow replica you see in the bottom right, to put all the colors in and all the decals and all the finishing touches to make it look like a true model. That part is much faster. In this case, it took about 8 hours, but it's dependent upon how much artistic look do you want the aircraft to look. So that 8 hours can easily go up. So what's really a good point to mention here is the 3D scan that we did within this hangar of the replica. This can be used for other reverse engineering applications. And case in point, for the 3D metrology application that Rob was talking about, and also especially for the application of visual components that Graham was talking about, the same technology can be used that if you want to create a simulation of your production line and the facility that production line is sitting in, you can easily take this technology, 3D scan the whole interior area of the facility that the production line is going to be simulated in, and bring that into the visual components platform. Therefore, you can then bring it into a virtual reality platform if you want to take it to that extent, to the VR extent. And so the time is dependent upon how complicated, how much information you want to be able to collect into your simulation, and therefore, if you choose a virtual reality setting. So what I'll do right now is I'll quickly show you a 360 view of the actual point cloud data that was collected, and it gives you a better appreciation. It'll be zooming in and zooming out. It'll give you a better appreciation of what data was collected, how and what processing needs to be done. So as you can see here, there's a video taken here, and it's showcasing the how the point cloud data look. It looks like it's a model from a distance. What you'll quickly notice is, momentarily, the video is going to be zooming into the actual points that was collected by the 3D scanning. You'll notice that the points are not connected. You can see they're literally just points in space. We're looking at the nose landing gear door, have the Avro Arrow replica, and you can see it's just points in space. There's no model here. And so this is the raw data that comes out of the 3D scanner. And here we're zooming into the main landing gear of the Avro Arrow replica. Again, point in case of how the points are just literally points in space. So that's why it took, in this case, for this project, it took approximately 40 labor hours of an engineer or designer sitting at a computer using the software at hand to make those connections, because there is some form of art involved with this as well, in order for the points to be connected to one another, so that it's truly representative of what you want it to represent. So I'll go to that's the air intake of the engine. So I will now stop this, and then we'll go to just one more slide. So here I want to show you basically a 360 video of the final rendered virtual reality quality level Avro Arrow replica model. So I'll take you to another 360 video view of the aircraft. So now this is the final product. This is the product that was delivered to our customer, and they're currently processing it and preparing it and using it to immerse into their virtual reality world that they're intending to use it for. And their specific applications is for sales and marketing purposes for what they want to do. But it gives you a very good understanding of the quality, the level of work that's involved, and the quality of what the final model product is. So it's really quite amazing what we were able to achieve. And I'll stop that. And that pretty much brings us to the end of my presentation, and pretty much the whole content and technical presentation that my colleagues provided. Ron, I'll pass it on to you.
All right, thank you very much, Roman, Graham, and Rob, for your presentations. We'll open it up now to any questions that you may have for our presenters. And I've got to start it off with a question for Graham. Yeah, there he is. When you guys calculate the ROI on a simulation, what are the components of it? Like, how do you, what things do you judge against the cost of doing a simulation in order to do an ROI?
Usually it involves identifying specific pain and dollar values that go along with it. The examples of failed launches, the examples of, what the floor space is worth, what a certain production increase would end up getting you. So usually it's pain over budget is, usually how we do it. And then we'll get in there and solve those specific issues, and really do that. So we don't just go in because it's a neat toy and people like pushing buttons, but it really as a tool to resolve those pain points.
Okay, thank you. And feel free to submit any questions that you have on the Q&A feature of Zoom. It's down on the bottom there. I've got another question here for Rob or Roman. Is just from a estimated dollars per for the equipment to be able to do, there was a video that was shown where the gentleman was scanning a fiberglass mold or a mold of some sort in order to capture the digital data. How much investment does it require to be able to set yourself up to do something like that?
You're looking at about $70,000 US, which would be for the scanner, the optical equipment, the software, and all that. And that may seem just some things behind that. There's a lot of infrastructure that system removes, such as not having to put targets on parts or anything like that, and being portable as it is. So in the video, it was shown as just being on a floor, being able to do a large part right here, right there. But that system can be packed up and gone to your sister plant across the street, and then measure some parts over there, or take it in line, take it to the vehicle. So it's about 75,000 US dollars to do that.
Okay. Okay. Thinking some of our manufacturers here have fiberglass molds for product that were just made by hand, and there's probably no digital record of them. And just from a business insurance perspective, if you want to call it that, having a 3D scan of those models in case something were to happen to those molds, you could quickly take those models and move them to a multi-axis milling machine and be able to make new molds rather than have to start from zip again, right?
Absolutely. And that's kind of very similar to that actual whole workflow that Roman talked about with the Avro Arrow, where on a mold case where you're going to actually go and remanufacture something, the integrity and quality of your data is everything. So starting off with really good high quality data, and then having a tool that will convert that scan data into surfaces that you can then go and cut to is the other side of the equation. But what used to take weeks and weeks is now into hours. I'm never going to say minutes, but the data collection may be minutes, but that CAD generation time is now in hours, for you then to be able to just 3D print a part in some scenarios, or give it to your CNC machine tool department to make another part, have it as a digital backup per se.
Okay, I got a question here from Slavka, and this is for you, Rob. What are the most common popular names of metrology software for working with 3D scan data?
So the most common software are out there. So Creaform has their own software. Polyworks is a very generic brand that talks to multiple devices. So there's Creaform, there's Polyworks, there is Gom Inspect, and then beyond that, there's some smaller players, and each OEM typically has their own products. Like Faro has its own product, Hexagon has its own product, but a lot of those products also use third parties like Polyworks as well, or Gom Inspect for that case.
That's great. And an add-on question to that does the list of recommended software change when you're focusing on reverse engineering, and why?
Oh, 100%. So there are really 2 or 3 reverse engineering packages out there. The number one that I think in the market, it's my preference, is called DesignX. It is a studio platinum level version that people to take data from area scanners, data from CMMs, data from handheld laser devices, and do your reverse engineering from. There are other products out there, things like VX Elements. Hexagon has their own new RE package. So there are multiple platforms out there to do this, but they are very different CAD packages than your traditional CAD or traditional metrology software package.
Okay, okay. For Graham, I got a question for you here in regards to when it comes to virtual production planning. A lot of people, I think of it as an add-on. It's just another step that you have to add to an existing process to get to where you have to go. But when we talked prior to this presentation, you were mentioning that it actually shortens the timeline between product design and launch, because you can do the engineering and the design and the production planning simultaneously. Can you dig into that a little bit?
Yeah, absolutely. This kind of plays into that cradle to grave, where you capture that concept and idea in a sales environment using predefined and preset up equipment, where you understand what that's going to look like and what's realistic and what's not. The great thing about it is you're not using a sales tool and then trying to transfer the data to the engineering team, so they have to start over. They're not taking PowerPoints, they're not taking flow charts and then trying to make sense of it hoping they get it right, having to reconfirm with sales what the, what the goals were. And it really, creates kind of like a seamless transition where it's like, here's the data, here's the process. The engineers are on the same page. And then again, even to the very end for controls and offline programming. It really is that same platform where there's no need for, for specialized softwares and multiple engineers and multiple disciplines, because that same platform provides the same data to all of the different people and departments and processes involved. So it really just helps that communication because everybody's speaking the same language.
That's good. That's good. Thank you. Thank you. No, I'm old enough, Graham, to have worked on AutoCAD 1.0 on an IBM with two 5.25-inch floppy drives and no hard drive. So I go back to the era where the design department would have to finish something and then it kind of gets thrown over the wall to production engineering and they do their thing, so that you've got the one task can't happen until the other one is finished. Now with the whole virtual production planning, as the model is created and before the drawings and the process information is created, the process can actually be created virtually, right?
Yeah, the process can then be created, and then, through certain simulation packages and platforms, you can actually export the flow charts after you've created them. You can export the 2D CAD from the simulation environment. You can do a lot of stuff. So yeah, you're not limited to, A, B, C, and D. You can kind of do them all at once. And again, it becomes that platform for communication.
That's great. Thank you. Thank you. Are there any other questions out there? We're just going to leave it open here for about 30 seconds to see whether anything pops up. And if not, we will sign off. All right, I don't see anything else coming through. So Roman and Graham and Rob, thank you very much for your presentation today. You see their information up on the screen there. If you want to get a hold of them to discuss anything that you have going or need more information. There will be a recording of this webinar that will be on our website more than likely tomorrow and at vtci.ca. So if you missed parts of this or want to go back and watch other parts of it, feel free to go to our website. The other thing, Graham, you said you were going to share your presentation. Roman and Rob, are you able to do that as well? Yeah. So if you want a copy of their presentations, feel free to email me, and I will fire it out on behalf of CAD Micro and Visual Components. So with that, we are going to sign off. Thank you very much for your time, and look forward to our next topic on hydrogen fuel cells and hydrogen filling station technology in next month. Thank you.
Thank you very much, everyone. Thank you, Ron.